Great. So hello, I'm Grant Herman, and today we're going to talk about Emscripten, and the future of browsers. So before I begin, I'm going to do a little background. I'm going to gloss over this. These are kind of complex topics, but I'm going to skim over them. You can do more research in your own time. So interpreted versus compiled languages. In the beginning, we kind of talked about just-in-time compilation, which I'll go further into in some future slides. But essentially, what I want you guys to take away from this is, theoretically, there's two types of computer programming languages: interpreted languages like JavaScript, compiled languages like C. A really good explanation I one time read was, think of your computer as almost like an alien. You have these human-readable languages like JavaScript or C, and you need to get your human language for the computer to understand. So you can either do interpretation, like in the UN when someone speaks, someone's just translating, or you could almost pre-write down your document and then give it to the computer so it knows what's going on. Some of the advantages are interpreted languages are a bit easier to use, but they're not as optimized as languages that are compiled. So how is JavaScript run in the browser? So JavaScript originally was just interpreted in the browser, and Chrome and Firefox and Safari, not Internet Explorer, but maybe Safari, they wanted to speed up how they were running JavaScript. So they kind of ripped a page out of the compiled languages book and started doing something called just-in-time compilation, which is supposed to be this best of both worlds. I go into a little bit here on what's actually going on. Certain code that's being run multiple times. The browser is able to figure that out and is not going to always compile that code. All right, great. So the core of what I'm trying to get at today is, what is Emscripten? So Emscripten is an open source compiler, essentially, and it compiles C and C++ code into JavaScript, or transpiles this code into JavaScript through a language called Asm.js, which I'm going to get into in some future slides. But what I want to be really taken away from this is a tool that's used to take, in this case, lower level languages and move them into JavaScript. This has also been done, as it says at the bottom, for Python and Lua. So Emscripten kind of opens up a lot of opportunities to run code in the browser, that code languages that maybe weren't necessarily made for that purpose. So what is Asm.js? I think this is actually more important than what is Emscripten, just because this is something that is starting to get a lot of traction, and this is actually being able to be used in browsers currently. So Asm.js is this subset of JavaScript, which is kind of this intermediary language that when C is moving to JavaScript, that's what it's transpiled to, or that's what it's converted to. And so in Asm.js, the way that they're able to make it a bit faster than JavaScript is they are actually able to do some type checking. And I'll show you some code that shows you how they do that. But Asm.js and Emscripten is being adopted by a lot of game engines. So you're able to run games in the browser faster because you're not worrying about JavaScript. You're actually using this lower level kind of version of it. So here is an example. Obviously, it's a pretty simple example, but I think it's very showing of what the differences are. So here on the left, we have C code, which is returning just a number. You're taking in, we know from this function here that we're going to be returning an integer, and we're going to be taking in an integer. So that's very helpful. So over here we have the Asm.js code. And so we have a function, right? This is JavaScript. We've all seen these things. And so here, as you can see with the I variable, we have this pipe and 0. And then all of a sudden you see it at the bottom as well in the return statement, which kind of looks strange, but that's how Asm.js is actually kind of skirting is kind of making it statically typed. It's able to tell the browser, hey, this is an integer. This is also an integer, whenever they see this. So it's a way, the reason why it's able to run faster is because now, instead of having to interpret what is this variable, what is this doing, the browser is able to see immediately, okay, that's a number, and let's keep moving. And so before I talk about these, I want you guys to keep in mind that this was something that was published by Firefox. So I don't know. I think it's definitely made with their, them as being superior in mind, but it's important to just take the information. So here you can see, in terms of running time, they have Firefox, Chrome. Again, Firefox made this, so Chrome is just vastly slower. But here at the bottom, which is what I want you guys to see, is this green and yellow bar. And so the green bar is Asm.js running in the browser, and the orange or yellow is native code, C or C++, running on an actual computer. So as you can see, are we getting to exactly native code or C code on the computer right now? No, but we can see there's a significant reduction in the speed, which is really great. So why do you care? And what I really want you to take away from this is the web development is this ever-evolving kind of discipline or field, and things are just kind of getting faster. Browsers are ever-evolving, the languages are ever-evolving, and what's being able to be done in the web or in the browser is kind of vastly expanding. And another thing I want you to take away is this doesn't mean that JavaScript is over, which is something that people say all the time, is why do you need JavaScript? I can just write C and it's going to turn it into JavaScript for me. A lot of these tools that I'm going to go over in the next slide, but a lot of the tools that are using Emscripten and Asm.js, they need JavaScript still to run with it. It's usually a pair with JavaScript, not a replacement. So what next? So a bunch of technologies that are gaining a lot of traction is really WebAssembly. Google Native Client, I think, is a little bit more, it's not as widely used. WebAssembly is still not in any production applications that I know of. But WebAssembly uses Emscripten and Asm.js before it turns low-level bytecode for the browser. So I guess what's the important part is that things are changing. You're able to make faster and faster applications. What you can do with applications is getting wider and wider, and we're getting to the point where there's going to be some really powerful applications in the future that we can do using tools that are using these lower level Emscripten and Asm.js. Thank you.